All right, so with rationalizing the denominator here in the review for 7.1 to 7.4, okay, first thing you want to do is break this up to the square root of 5 over the square root of 6. And then we're going to rationalize by multiplying the top and bottom by root 6 over root 6. It's going to give me root 30 over 6. And then I want to look, Sarah, and I want to see, can I simplify 30? And the answer is no. So then I move on to the next problem. With number 11, it's a little quicker, a little easier. All right, there is one catch, and there's one thing I'll be looking for on the quizzes, and I'll kind of like ding you for some points here if you forget to do it. So on this one, okay, we're going to multiply by root 10z over root 10z. That gives me 4y root 10z, not much I can do on top, over 10z. And Marcus, this is where I'm going to hit you for some points. 4 over 10. 4 over 10, you can simplify, right? So I'm looking for you to simplify to 2/5 y z, not much changes there. But then we have the root 10z. Do you see that? How I just simplified the 4/10? Okay, so that's what I'll be looking for. All right, in number 12, okay, this is straightforward. The variables, and what I mean by variables is the 5th root of y plus the 5th root of y, they're the same. So 2 plus 7 is 9, so it's 9 times the 5th root of y. Okay. Now in 13, there's a little bit more work to be done. Okay, so Rachel, this one, it's understood that there is a 2 outside. Okay. Implying that square root. What's the square root of 4, Rachel? 2. So the 2 is going to come out. Now I'm going to see how many times does 2 go into 5, Rachel? Twice. So I have an x squared. And what was my remainder? 1. So there's 1x on the inside. Are you okay with that, Rachel? For the second piece, there's already an x outside. All right. But now I got to try and break down that x cubed. Ariana, how many times does 2 go into 3? 1. So one more x comes out. How many are left over? So 1 stays on the inside. And now I have 2x squared root x minus x squared root x. Now my variables are the same. Okay, I both have the x squareds and I both have the root x. See that, Owen? So 2x squared minus 1x squared is simply an x squared root x. Fair enough? Mr. Emmy, with this one, with 14, okay, we have these cube roots. So I'm going to sort out by having that cube root there. Do you see that? 3 goes into 9 3 times. Whoop. Okay, and 3 doesn't go into the y. All right, it's just 1. So I have the x to the 3rd times the cube root of y plus now I'm going to see how many times does 3 go into 3? That's 1 time. And how many times does 3 go into that 1? Well, it can't. So now I have x cubed times the cube root of y plus x times the cube root of y. And the problem here is this. My kind of variables look very similar, but they're not. I have an x cubed and an x. Okay, not much I can really do there. The only thing I could do if I want to be fancy, Mark, I can just take out that cube root of y. All right, but I'm not going to really be worried about that too much. Okay, Mr. Schuler. All right, with 15, Mr. Schuler, I'm looking for cube roots, right? Now that y is already outside, right? I'm not going to worry about that. I'm just going to keep them outside for now. 25. Let's break down 25. Give me two numbers that go into 25. Can you break down 5 and 5 any further? No. So notice 25 doesn't have a cube root. I can't take anything out because I only have pairs of numbers. So 25 stays inside. Now let's deal with that x to the 5th. How many times does 3 go into 5? So 1x comes out. How many stay inside? That's my remainder. 2. Because x went in, or 3 went into 5 one time with a remainder of 2. Remainder stays inside. Okay? So it's yx times the cube root of 25x squared. Now, this one's a little tricky. Okay? -3. We didn't really talk about that, right? But -3 can be looked at as -1 times 3, right? So I see you have your calculator out. Thank you. Can you do the cube root of -1? Tell me what that is. Cube root. You did square root. Because remember, cube root is under math, right? You get down to like number 4. -1. So I'm going to pull that out, okay? So it's -1, okay? And I have this cube root 3. We can't break down 3, right? So 3 stays on the inside. Now, does 3 go into 2, Mr. Schuler? No. Does 3 go into the 3 with the y? One time, right? And there's none left over. Now, Mr. Schuler, there's no sense in going any further here because these cannot be broken down any further. They can't be combined any further. So I'm done. Okay. It's very fitting that we're going to be talking about the next problem, Mark, because I know you're a big TikTok guy. And all over TikTok is how outrageous the price of wood is, right? What TikToks are you following?
I'm on the other side, I guess. I don't see anything about
You're
the
on the-
price of the wood.
Does anybody see that on TikTok? Nobody sees that? All the time. It's ridiculous. It's all my FYP is. Just wood prices. It's crazy. Unbelievable. No, you guys didn't hear about this?
I know that.
You know about it? Yeah, so when COVID happened, there were like a lot of building and stuff like that. So there was like a surplus of wood. So wood prices went down to like record lows. But then like the wood just kept coming in and flooding like Home Depot and Lowe's and all those places. Because like the stop, like because of COVID, didn't like it took time to hit the stores. So the wood kept coming in and drove the prices down. But now that everything's opening back up, like they have to ramp up their productions and stuff like that. And it's just taking time to get it all back in. So like a sheet of plywood went from like $35, $38 a sheet of 4x8. Now it's like $70. So if you need to get like anything done to your houses, don't. I feel bad for anybody that needs like a new roof. It's just building a deck. Ask him about it. And be like, yo, how are the prices of wood? He'll be like, insane. He'll just get grumpy. He'll probably be, Zach, go do chores. Just something ridiculous. All right. Yeah. So yeah, it's crazy. So here we go. All right, Mark. Corners are cut from a sheet of 4x8 plywood. Okay. Now Maggie at home is probably going to do really well on this because she remembers her geometry. Do you? You do? Okay. We're going to find out. 1, it says perimeter. What is that?
On the outside, though.
Yeah, it's like the distance around. I kind of think of fencing, right? Right? Like how much fence do we have? It's like, all right, well, what's the length of my property? So Mark, I'm going to cut off these pink pieces from my plywood. But the problem is I want to know what is the perimeter of the hexagon in the middle. Okay, meaning I need to figure out what is the length of that right there. And notice I use the letter C, right? Do you know any formulas that involve triangles? And the letter C. We're going to focus on this triangle right here. Mark?
Half is involved. And I think it might be
No.
what? triangles, half is not involved.
Not, that's area. It's
Remember.
very famous.
Y equals mx b.
No,
A squared plus b squared equals c squared.
very good. Do you know who invented that?
Albert Einstein.
Pythagoras. You were close. Pythagoras. So we're going to do a squared plus b squared equals c squared. A and b are my lengths of my legs. So they're both the same. And this is why I said Maggie's probably going to do very well on this. Because, Mark, do you remember your special right triangle formulas? No. If you did, okay, if you did, you would see that this is a 45, 45, 90 triangle because the two sides are the same. So you would come up with, when you did this, you'd come up with your answer of being for C, 4, 2 and 2, as C equals 2 root 2. So the special right triangle for 45, 45, 90 is, all right, leg, leg, leg root 2, or x, x, x root 2. Okay. So it was 2 root 2. If you remember that, you could have gotten it pretty quickly. Now, Mark, I have 4 sides here that are 2 root 2. Do you see that? See that? I have 4 sides. But I have to figure out, Mark, how long is this piece right here? This is 2. This is 2. Very good, Mark. That's 4. Meaning that's 4. So, Mark, my perimeter will be 4 plus, right? How many 2 root 2s do I have? 4. How many 4s do I have? Okay, so I'm going to have 4 times 2 root 2 plus that other 4 on the bottom. That's going to be 8 plus 8 root 2 feet. Mark, even though you, had geometry last year, right? Who's your geometry teacher? Warner. She's very nice.
Yeah.
Very nice. Okay. Looks like you still came out on top. She taught you some math well. There we go. All right, Jagger. For these guys, nothing too fancy. We're just going to distribute that 12 throughout. So root 12 times root 6 is root 72. Easy enough, Jagger? Root 12 times root 8 is what? And then we just want to break these down. I'll give you a second to break them down. All right, I broke down 72 and 96 to 36 and 2 and 24 and 4. 36 was broken down to 6 and 6. I picked that because I got a pair of 6s pretty quick. So root 72 became 6 root 2. Root 96 with the 24 and 4, it broke 24 down to 6 and 4. And then circled my pair of 4s, and 6 can't break down any further. So it became 6 root 2 minus 4 root 6. Miss Greg, you okay with that? You doing all right? All right. Kelsey, are you doing okay?
Yeah, I'm good.
All right. Himpu, you doing all right?
Yeah.
Once. Just one time I wanted to say something other than you. One time. Do you think I'll get it? Do you think I'll say something other than yeah?
Also, yeah.
All right. With 18, we're going to distribute that root A So root A times 4 is 4 root A. And root A times root A, this is pretty easy. That's root A squared, or they just undo each other. So it's 4 root A minus A. Mr. O'Donnell, you okay with that? All right.
I have a question.
Whoa, that's 2 questions.
Yeah.
You said I have a question, which implies you have 1. This is me breaking down some English here.
Okay.
Okay. So you said, can I go to the bathroom? That's 1 question. And then you said you have a math question.
Yeah.
So the only thing I'm hearing is that you're lying to me right now. You have 2 questions.
I do have 2 questions.
How can I work in this environment? No, I'm kidding. What's up?
If we like break down the 96 and get those 2 4s, how do we know that we need just like 2 of them?
It's square root. Great question. If it was like cube root, you would need like 3 4s.
All right.
Okay, but notice I didn't put a 3 out there. It's understood that it's a square root. It's 2. Okay. All right. Let's look at 19.
Can I ask the second question?
Is it, can I go to the bathroom?
It is.
Yeah. All right, Sarah. Root 18 plus 5 squared. What does that mean? Yep. So what I'm going to want to do here is I'm just going to want to rewrite this as root 18 plus 5 times root 18 plus 5. This is going to allow me, Sarah, to draw my arrows and actually multiply it out and see it easier. Root 18 times root 18, all right? Root 18 times root 18, they undo that square root because it would be root 18 squared. All right, if you don't believe me, I believe 18 times 18 is 324. Could be wrong on that. But the square root of 324 is 18. So we have 18. Now I have root 18 times 5. That's 5 root 18. Now I have 5 times root 18. That's another 5 root 18. And then I have 5 times 5. That's 25. Sarah, do you see how I did that through FOIL? So now I got to clean this up. All right. I have 25 and 18. That's 43. Move that a little lower. Plus 10 root 18. But the problem with this is I have that root 18. Okay. And it's not like, surely it's not like everyone's going to be able to be broken down, but it's like I always have to ask that question, can I break it down? All right, because simplifying is where I'm going to get you. So Sarah, with 18, can I break it down? To a 9. I'm glad you picked 2 and 9 because 9 is 3 and 3, right? So that 3 is going to come out, but there's already a 10 there. So it's 10 times 3. So this is going to be 43 plus 30 root 2. Because that's what was left. So what I typically do on this, 2 legs coming off of it, right? The 9 has 2 legs coming off of it. So 3 times 3 times 2 is 18. 3 times 3 is 9 times 2 is 18, right? Yep. So notice I had a pair of 3s, so that came out. And the fact that 2 didn't have a partner, he had to stay inside. Kind of think of it as the remainder. Can I erase this there? All right. Ariana, with number 20, I'm just going to distribute that root 32. Root 32 times root 2 is root 64. Do you agree? Root 32 times 9 is just 9 root 32. Do you agree? Negative 7 times root 2 is negative 7 root 2. You okay with that? And negative 7 times 9, that's negative 63. Are you all good with that? Now here I need to break these things down, right? Square root of 64 is 8. Now 32. Can you give me two numbers that go into 32? I don't have a lot of room, so give me a good one. Don't give me 8 and 4. Oh. You couldn't give me 16 and 2? Oh, 16 and 2. I like 16 and 2. The reason I like 16 and 2 is 16 is 4 and 4. See that, Ariana? 8 and 4 is fine. Just give me a hard time about it. But I just don't have a lot of room because it would just go down too far. So 8 and 4 you would break down, and then 8 would be broken down to 2 and 4. And then there's your pair of 2s or 4s. So here we have 4, but there's already a 9 out there. So 9 times 4 is 36. You okay with that? So it's going to be 36. And Sarah, notice the 2 didn't have a partner, so that guy stays inside. 7 root 2, Mr. Schuller, this is what I was telling you about. We can't break down 2. So we're just going to stay there. Minus 63. Now, we have two things here. We have 8 and a minus 63. Does everybody see that? Combine them. 8 minus 63 is negative 55. 36 root 2 minus 7 root 2. Well, 36 minus 7 is 29. It's doing so well. And now it's not. Minus 55 plus 29 root 2. Sorry, Owen. It's kind of like the Phillies. You get what you get, and you don't complain. Yes. Yeah. Are you jealous, Marcus? I didn't give him a hard time.
Nah, because he only had one question.
You only have one question. All right. All right, down here, hopefully you guys found a pattern with conjugates. Did anybody find an easy way to do the conjugate? Oh, it is. Now, but when I multiply them together, that's where the pattern occurs, right? So this was root y plus 2, right, Owen? And this one over here is root 8u plus root 5. Agreed? You okay with that? But Owen, there was a pattern. Okay. Did you happen to find the pattern for simplifying the conjugate times, I guess, the expression here? Did you happen to find one? Very good. It's actually called the difference of two squares. So what Owen's saying is, with this, we have two parts here. We have the first term and the second term, right, Owen? So Owen's saying, all right, to simplify the answer, it's just going to be the first term, which is the square root of y, times itself, which is squared. So root y squared is just y. And Owen said, we have the second part, which is 2 squared. That's 4. So it's y minus 4. Owen, is that the pattern you found? I'm really glad you were able to find that pattern. Otherwise, these problems get pretty difficult. Owen, what would you get for 22 then? 8u? 8u minus 5. Because he's doing the square root of 8u squared minus the square root of 5 squared. And it's always minus, right, Owen? Always minus. Nicely done, Owen. Thank you for finding that pattern, saving me some time. Now, the reason why it's useful is when you're coming up with simplifying these expressions, so we have to rationalize the denominator. All right, in 23, we multiply by 2 plus root 6 over 2 plus root 6. So now what we're going to do is we're going to kind of distribute this 5 root 3 inside. It's going to be 10 root 3 plus 5 root 18 over. And then Owen taught me it's going to be the first thing squared. So 2 squared is 4 minus that root 6 squared. So root 6 squared is 6. All right, with this one, we have to break down root 18. Root 18 broken down is going to be 9 and 2. Square root of 9 is 3. So it's going to be 10 root 3 plus 15 root 2 all over negative 2. All right. Now I do have 2 more problems on here, but I'm not going to be able to go through those. Okay.